Solid Figures, Topic 18-1 from Envision Math 6. In this topic, we are looking at the attributes of solid figures. When we talk about a solid figure, we are talking about a 3D figure, something that has height, length, and depth. So first, let's look at the definition of a polyhedron. Polyhedrons are three-dimensional figures made of flat surfaces. These flat surfaces are polygons, and we call each one of these polygons a face. So a polyhedron must have straight edges, just like a polygon, and it must be a closed figure. Our next definition is a face, which is the flat surface of a polyhedron. If you look at this figure below, a face would be one of these flat edges right there on that cube, which is a polyhedron. An edge is the line segment where two surfaces meet. So if I look at the face colored in red and the face colored in blue, this line where those two faces meet would be considered an edge. On our diagram here, this arrow is pointing to an edge right there. Last is vertex, the point where several edges meet. So again, if I look on my diagram here, if I look at the top face, this side face, and the other side face, the vertex would be the point where all of these are meeting. So here is a vertex, here is a vertex, and so on. All of these points are going to be a vertex. So let's look at these two solid figures and determine how many faces, edges, and vertices each one has. If we look at the first figure, and I'm going to look at the bottom of the shape first, I have one face on the bottom, and then this is a six-sided figure for that base, which is a hexagon. So that tells me that there are going to be 6 sides on this pyramid. So if I have one on the bottom and then the 6 sides going around it, that's going to give me 7 faces. Now as far as the edges, I'm going to have 6 edges where each of the faces around the pyramid meet, and then 6 edges on the bottom where each of those faces on the pyramid meet the face on the base. So 6 plus 6 is going to give me 12. Now when I look at the vertices, I'm going to have 6 points around the figure and 1 point on top, which is going to give me 7 vertices. Now for the cube. It looks to me like for faces, I have 1 here on the bottom and 1 on top, so that's 2. And then I have 1, 2, 3, 4 going around the figure, so that's 6 faces. Edges, I have 4 on the top, which means I'll have 4 for that bottom face. And then going around the figure, I have another 4. So it looks like that will be 12 edges. And then for the vertices, it appears that I have 4 on that top edge and another 4 on the bottom. So that will be 4 plus 4, which will give me 8 vertices. Now let's look why these examples and non-examples here are not polyhedrons. The top row, these are all prisms made out of polygons. So each face on the top 3 are made up of polygons. If I look at the bottom here, this cylinder actually has a circle on the top and the bottom, and we know that circles are not polygons because they are not made up of straight lines. So that knocks that one out. My sphere is a perfect circle here. it doesn't have any flat faces at all. So without flat faces, it cannot be a polyhedron. And the last figure here on the right, although it does have a vertex up here, if you look at the base, that is again a circle, and since polyhedrons are made up of polygons, which are the faces, having a circle on there for one of the faces will keep it from being a polyhedron. Okay, for these next definitions, first we have pyramid. A pyramid is a polyhedron with a single base. So if we look at this pyramid here, the base here would be a triangle, but you will notice that we do not have another triangular base opposite it. If we did, it would look like this and be a triangular prism. But since we don't have another base there, another triangular base, this instead fits the definition of a pyramid. A prism is a polyhedron with two congruent. Remember, congruent means exactly alike. And these polyhedrons are going to be congruent, parallel, and polygon shaped for bases. So if we look here at this rectangular prism on the left, I have a rectangle that is considered a base on top and a rectangular base on the bottom. These two are parallel, meaning they are exactly equidistant from each other on every point of their surface, and they are both polygons. If we look at the next prism, we have a pentagon on top and a pentagon on bottom, which form the two bases. Again, they are congruent, exactly equal, and they are parallel from each other. Now, if you notice, the pyramids and prisms are both classified by the shape of their bases. The first one over here on the left is a rectangular prism because the base is a rectangle. Then we have a pentagonal prism, named for the base, triangular prism, and then you will notice the pyramids have the same exact feature. This is a triangular pyramid because the base is a triangle. This is a rectangle pyramid because the base is a rectangle. And this last one here is a hexagonal pyramid because the base has 6 sides. Now your last definition for this unit is a net. A net is a plane figure, meaning flat, plane figure pattern, which when folded makes a solid. So if you look over here at this net on the left, if we were to fold it up along these dotted lines, it would form this pencil box, which is a rectangular prism. On the bottom, at the center of this net, we have a pentagon, and we have another pentagon reaching, or on the end of one of these rectangular pieces here. If we fold that one up, it would form this pentagonal prism here. So this would be called a pentagonal prism. Our next net has dotted lines right here, so if we were to fold it up, it would form this triangular pyramid. And the last one would have these two circular faces with this rectangle wrapped around it, so it would form a cylinder. Now keep in mind that even though shapes like the cylinder and the sphere are not considered polyhedrons, they are still 3D figures because they have height, depth, and length. They're just not classified as polyhedrons because they don't have those straight lines. Now you try. Go ahead and classify each 3D figure. What I mean is name the shape, pause the video, and when you hit play again, I will reveal the answers. Okay, our first figure is a sphere. Our second one is a cylinder. Our third is a rectangular prism. You can see there is a rectangular right here, and there would be an identical rectangular base on the bottom. 4 is a cone, and 5 is a hexagonal prism. Now you will notice that the hexagon shape here is not actually on the bottom of the figure. They've turned it so that you can see there is one hexagon here, and then there would be an identical one on the back side. 6 is a rectangular prism when it's folded, and 7 would be a triangular prism when it is folded. The rest I will be saying instead of writing down, so you better listen to check your answers. 8 is a square pyramid based on the shape of its base, which is a square. 9 is a triangular pyramid, also based on the shape of its base. 10 is a cube. 11 is a triangular prism. 12 would be a square pyramid based on its base. And 13 would be a cube because all 6 of those face pieces look to be identical in size. Now go ahead and do your quick check and see how well you understood today's lesson.